Yes, Tofan, you want to say anything?
No, sir, no, sir.
Okay. Let's wait for another 2 minutes, then we will start the discussion. I'm actually waiting for everyone to join in, so it will be easy for me.
Okay, sir.
Okay. So, good evening, everyone. My name is Ayan Paul, and I am your TA for this session, problem solving session, week 2 discussion on this course, Introduction to Soft Computing. I have taken the class previous week also, but this week I am seeing all the new participants. So, can we have a brief introduction about yourself? 2 line brief introduction. One by one, if you will introduce yourself, it would be good for the class. The other participants would also know.
Hello sir, my name is Ayush sir. I am from Chandigarh sir.
Okay, nice. Your educational background?
Yeah, I am currently studying in Chatkara University, Himachal Pradesh,
Okay, okay, very nice.
pursuing my computer science engineering.
Okay, okay, very nice.
I am loving this course sir.
Okay,
Actually I am follow this course by week only.
okay, okay, very nice.
Thank you sir.
Next one.
Sir, my name is Tofan Pole. Currently, I am pursuing my master's degree in Institute of Management and Information Technology, sir. I am from Puri.
Okay, okay, very nice.
Thank you, sir.
The other guys?
Good evening, sir.
Yes.
I am Suneshwar Prasad. I am currently pursuing my MCA in IMIT Qatar, and I am from Odisha.
Okay, okay, very nice.
I am Shankar from Chennai. currently retired, taking this course just to gain some knowledge.
Okay, okay, very nice.
Good evening, sir.
Yes.
I am Upit Kumar Jana from IMIT Cuttack from Odisha.
Okay, okay, very nice. Anyone else?
Good evening, sir. Myself, Nanda Kumar. I am a research scholar. Soft computing is very useful for me because I am a research scholar. I am going to take that subject for my coursework. That's why I am take this part of the course, joining this course.
Okay, so you are doing research on which topic?
Sir, VLDC motor relevant to soft computing relevant to our area, sir.
Okay, okay, very nice.
Yeah. Thank you, sir.
Anyone else? Vishnupriya Sahu. Would you like to unmute yourself and speak?
Good evening, sir.
Yes.
I am from Odisha. I am pursuing MCA for GATE College, Barampur.
Okay, nice, nice, very nice.
Thank you.
Okay, so let me share my presentation. So I am starting my presentation. Is my presentation visible?
Yes, sir.
Okay.
Yes, sir. Yeah.
Okay, okay, very nice. So, good evening everyone. My name is Ayan Paul. I am a PMRF research scholar from IIT Kharagpur, and I will be your TA for this problem solving session, Introduction to Soft Computing, and this course is taken by Professor Devashish Samanta of Department of Computer Science and Engineering, IIT Kharagpur. And this is the week 2 discussion on 14 February. Last week also I have taken a discussion, similar type of discussion, and that video is uploaded on YouTube. I think you all got the links of that video and presentation, right? Am I right?
Yes, sir.
Okay, okay, nice. So, 1 minute, someone is joining. Okay, so today I will start my discussion with the difference with two-valued logic plus versus multi-valued logic. So, basic assumption upon which crisp logic is based, that every proposition is either true or false. So, first of all, what is the meaning of this English word proposition? Proposition means a statement that draws an opinion. A statement that draws an opinion is known as proposition. So, whatever. 1 minute, someone is joining. Okay. So whatever till now we have studied in our plus 2 or anywhere, we have studied the proposition known as crisp proposition. Crisp proposition has only two valued logic, that is true or false. True we denote it as by 1, and false we denote it as by 0. So this is known as crisp logic or crisp proposition. And this has two values, as I have told you, true and false. The classical two-valued logic can be extended to multi-valued logic. Now we know our real life problems are very complex. Like if we will take this statement that sun sets in the west or sun rises in the east, so this has only two valued logic or crisp logic. That is, either it will be true or either it will be false. False. So this is known as two valued logic. But otherwise, like our real problem, like if I will ask if you you will join a party or not, you might not say yes or no only. You might say maybe I will join, I will think. So this for all this we are extending this two-valued logic to this multi-valued logic. And example of multi-valued logic is, see, two-valued logic is true or false, 1 and 0. And multi-valued logic, we can have intermediate terms in between 1 and 0. It could be half for a three-valued logic, or it could be anything like 0.25 or 0.75, anything. So we are actually extending this two-valued logic to multi-valued logic. So fuzzy logic is nothing but this type of multi-valued logic. Fuzzy logic I have already started in the previous class also, and today also I am telling you that it is an extension of your crisp logic. And in fuzzy logic we are just extending this two-valued logic to a multi-valued logic. Now proposition in which the truth value belongs to the interval 0 and 1. Here 0 and 1 are inclusive, as 0 and 1 is denoted by this brackets. This bracket means 0 and 1 are inclusive. Excuse me, okay, so I was telling you sorry, there is some technical problem happening. Okay, so I am telling you about fuzzy proposition. Fuzzy proposition, the truth value belongs to this interval 0 and 1. That means it will be a multi-valued logic. The truth value can be anything in between 0 and 1, and another thing to notice is 0 and 1 are inclusive. That means fuzzy logic also can have this two logic, true and false, and it can have other logic like intermediate logic, like maybe or may not be, like that in between. So this is your fuzzy proposition. So I hope this slide is clear to you all, right? Hello?
Yes, sir.
Yes.
So you can write in the chats also what I am asking, so it will be better to respond, because if we will interact, then only we can know what is exactly our problem is happening. So that is why I encourage everyone to write in the chats or respond, so it would be nice. So I am moving to my next slide. So now fuzzy propositions are connected with some connectivities. So what are the connectivities? That connectivity could be AND. This sign is for AND operator. That connectivity can be with OR. This sign is for OR operator. This someone is joining in. Okay, so this connectivity can be with not. This connectivity can be with implication. This is the sign for implication, and this connectivity would be with equal to. So what is the meaning of all this? The meaning of all this we will see in this table. So not means it's not a set. So let me give you the example. It would be better. So like if P is a proposition that is telling T is hot, and truth value of P is 0.8. As I have already told you, the truth value in fuzzy proposition is between 1 to 0, with 1 and 0 inclusive. So here the truth value of T is hot is 0.8. So so if we will use this not connectivity, is written in a statement form as T is not hot, and T is not hot, it is denoted by this symbol, that not connectivity is denoted by this symbol. So we will use this symbol, not P, and the definition of not P is 1 minus TP. That means the truth value of this not P will be 1 minus 0.8, that is equal to 0.2. So second thing is or operator. So how we write or operator in a sentence? If we take this two proposition P and Q, P is, as I have already told, T is hot with truth value 0.8, and Q is another proposition that coffee is hot with truth value 0.6. So if we will use this or operator, so in statement we can write either tea or coffee is hot. So this is the symbol of your or operator, or P or Q. So how it is solved? It is solved by maximum of truth value of P and truth value of Q. Means we will compare this both this truth value 0.8 and 0.6, and we will take the maximum. So answer for this will be 0.8, as 0.8 is maximum. So this is the or operator, our or connectivity. Our next connectivity is and connectivity. So and connectivity is expressed by this symbol reverse V. So and connectivity P and Q. And how this statement is written? Statement is written as T is hot and so is coffee. So how to solve this connectivity? We solve this connectivity by taking the minimum of the truth value of the two. So what is minimum of 0.8 and 0.6? Minimum of 0.8 and 0.6 is 0.6. So our answer would be 0.6 for this connectivity. Our fourth connectivity is implication. Implication is given by this symbol that P implies Q. P implies Q, or we can also write this implication as not P or Q. So how it is written? It is written, see, if there is or in between, what we do is we put the maximum operator. So we will put the maximum operator. Not P means we will be using 1 minus TP. So maximum of 1 minus TP and dq. So if we will solve maximum of 1 minus TP, 1 minus TP is what? 1 minus TP is your 0.2. 1 minus TP is your 0.2 and TQ is your 0.6. So what is maximum of 0.2 and 0.6? Maximum of 0.2 and 0.6 is 0.6. So this is your answer for your implication connectivity. And implication connectivity is written by this statement: if tea is hot, so is your coffee. So this is the way you write the implication connectivity. And we will end our connectivity with equality connectivity. Equality connectivity, this is your equal sign that you know, everyone know. So equality connectivity is written as P equals to Q. And statement is given: tea is hot as coffee. And how to solve this equality connectivity? Equality connectivity is solved by this: P implies Q and Q implies P. So if you will simplify it, you will get this 1 minus TP minus TQ. So TP minus TQ is what? 0.2. 0.8 minus 0.6 is 0.2, and 1 minus 0.2 is 0.8. So your answer would be TP minus TQ is 0.2, so 1 minus 0.2 is 0.8. So your answer of fifth thing, that is equality connectivity, or tea is hot as coffee, will be 0.8. So I hope you got this slide. Can I get a response? Hello, is this slide clear to everyone? Okay, nice.
Sir, by solving by the expression, we will not get 0.2 and 0.8, I think.
Which one?
By solving by the equation P imply Q or Q imply P.
Okay, implication, right?
P imply Q, we will get 0.6, and Q imply P, we will get 0.8. If we take minimum, answer will be 0.6.
Okay, let me see. So which one you are asking? Which implication?
Equality,
which connectivity?
Equality.
Fourth one?
Yeah, sir.
Yeah, fourth one is implication. Implication is...
No, sir. Fifth.
Okay, fifth one is 1 minus TP minus 1 minus TP minus TQ. So when you will do TP minus TQ, TP is your 0.8 and TQ is your 0.6. So TP minus TQ will be 0.2 and 1 minus 0.2 will be 0.8.
Sir, this is by the formula, but I am doing by the expression.
Expression, okay. Let me see.
Like Q or Q imply P.
Okay, so let me see this. So P, the implication PQ means this one minus TP and TQ maximum. 1 minus TP is 0.2 and TQ is 0.6. So maximum of 0.2, 0.6 is 0.6. Okay, very nice. And then we will do minimum of QP 1 minus TQ 1 minus TQ is 0.4 and TP will be 0.8. So maximum 0.8. So here okay, this, I think this sign would be this one.
Okay, sir. Got it.
Okay, now it is clear, right?
Yeah.
Okay, very nice. So please respond like this, so our doubt would be clear. So very nice. So can I move to the next slide?
Yes, sir.
Okay, nice. So our next topic is fuzzy implication. So we are done with this fuzzy proposition. Now fuzzy implication. So what is this fuzzy implication? Fuzzy rule or conditional statements. This assumes the form: if x is A, then y is B. So actually fuzzy implication means we are drawing a conclusion without explicitly telling. Like we are not telling y is b. We are telling y is b only if x is a. So this is known as fuzzy implication, and fuzzy implication is given by this relation. Relation a tends to b. So this is fuzzy implication, and fuzzy implication is done. Fuzzy implication is done in two ways. One is interpretation of as A coupled with B. So let me use my pen. Yeah. So in this for fuzzy implication, the same sign you will write R. A tends to B, and that will be equal to A cross B. And to solve this, we use four operators. These operators are known as T norm operators. This is a very important thing, T norm operator. And different T norm operator are first one is your minimum operator. In minimum operator, what you will do is take the minimum of the membership function. So this A and B is nothing but your membership function of element belonging to A set, and B is membership function of element belonging to B set. So if value of A is like 0.4 and value of B is like 0.6, so if we will use this T norm operator or minimum of T norm operator, then it will be equal to minimum of 0.4 and 0.5, that will be equal to 0.4. So this one, excuse me, and I think someone is joining. Okay, so minimum operator, I think it is clear. It is a easy thing. Just you have to do the minimum of the membership function of these two sets, and this you will do for the corresponding element. Like if x1 is there in set A, then you have to do this do the same thing with x1 of set B also. So this is applicable to same elements. So this is the first T norm operator. The second T norm operator is algebraic product. So nothing, you have to just do the product of both this membership function. And third T norm operator is your bounded product. Bounded product, in the bounded product, what you have to do, you have to take take the maximum of 0 and A plus B minus 1. Like A is your 0.7 and B is your 0.5. So 0.7 plus 0.5 is 1.2. 1.2 minus 1 is 0.2. So 0 union 1.2, the max 0 union 0.2 will be equal to 0.2, as 0.2 is the maximum. So this is your bounded product, and third is your drastic product. Drastic product is again a very simple thing. It is A if B is 1. Like if your membership function x1 is 1, then it will be equal to your A. Like A could be 0.4 and B could be 1. So here what you will get 0.4. And next is B if A is 1. Like if x1 is if membership function of x1 is 1 and membership function of x1 in set B is 0.3, so it would be equal to 0.3. Now if both are not 1 and less than 1, like 0.4 and 0.5, then with this drastic product you will get 0. So this part I think clear to all.
Yes sir, yes sir.
Okay, so this is the first part of your fuzzy implication, and this is known as A coupled with B, interpretation of A coupled with B. Now we will move to the next part, interpretation of A entails B. This is
Sir, I have any question, sir.
Yes.
Sir, in question, sir, the T-norm operator is given or not?
T-norm operator, yeah, very nice question. If see, if you will get standard question, then T-norm operator will be given, that which T-norm operator to use. But if
Yes.
in case T-norm operator is not given and you are just asked to find A cross B, then you will use the first thing, that is minimum operator.
Yes, sir. Yes, sir. Okay. Thank you, sir.
Okay.
Okay, sir.
Okay. Some example values. Which one you want example values? Nantha Kumar. Nantha Kumar, are you there? I am audible, right?
Sir,
Sir,
yes.
give us some
Yes,
example
sir.
values. Put one more time.
Okay, one more time. Which one, for all or some specific one?
T norms operators are one minimum value to maximum value. Put some values and then explain. Sir.
Okay, so let x1 be point. Let A is your 0.4, right? And let B is your point 6. So in first T-norm operator, minimum of T-norm operator, minimum, as the word is minimum. So you have to take the minimum of 0.4 and 0.6. So minimum of 0.4 and 0.6 is what? 0.4. So this will be your answer for the first operator. Second is your algebraic product. So what you have to do? Algebraic product, again you can guess with the name only, that only you have to do the product of this two. So product of this two is 0.4 into 0.6, that is equal to 0.24. So your next answer will be 0.24. Third one is your bounded product. Bounded product is maximum of 0 and A plus B minus 1. So A plus B minus 1 is what? 0.4 plus 0.6 is 1. 1 minus 1 is 0. So 0, 0 or 0. That means we have to do the maximum operator, because we have this union in between. So 0, maximum 0 is what? 0. So third answer will be 0. And fourth is drastic product. Drastic product says that it would be A if your B is 1. So is your B 1? Your B is not 1. Your B is 0.6. So this would not be applied for our question. Our second thing is it would be equal to B if A is 1. So is your A 1? A is not 1. A is 0.4. So again it is not applied. So third is 0 if A and B is less than 1. So A and B is less than 1. A is your 0.4 less than 1. B is your 0.6 less than 1. So your answer would be third thing, that is 0. So I hope it is clear, Nantha Kumar.
Yes, sir.
Okay, it is clear, right?
Yes.
Okay, very nice. So next part is interpretation of A entails B. So A entails B, we have three things. One is your material implication. Material implication is not A or A complement. This is the sign for A complement. A complement union B complement. Union, you know, union in union you have to do the maximum. So first you will calculate A complement. A complement, how you will calculate? You will calculate A complement by 1 minus the element. One minus element. I hope this is element written. Actually there is some technical problem that I am facing, but it is element written, right? So 1 minus element, A complement, and union B. Union B means you have to do the maximum. So you got this A complement thing, you got this B thing, you have to do the maximum of this two. Second thing is propositional calculus. Propositional calculus is calculated by this formula, that is A complement union A union B. So first you have to calculate this very part, A union B. A union B, how you will calculate? You will calculate by putting the maximum operator, because union means maximum. Then you will calculate this A complement, and when you calculate this A complement, you have to do the again you have to do the maximum, because again you have this union over here. So 3 steps. First is A union B you will find out. Second step is you will find out A complement, and then you will do the union of this two, A complement and A union B complement. And propositional calculus, another important propositional calculus is here that I have not written here, but I will explain you in your assignment part. And there another propositional calculus is there, and there you are just changing this union value A union B as A intersection B. And this I am discussing because this is very important. This is known as Zadeh's Max-Min rule. So I will tell you how to do this question, but you just as of now you just remember this, that in propositional calculus, if we change this union to intersection A intersection B, then that type of calculus is known as that type of rule is known as Zadeh's Max-Min rule. So that I will discuss in the question part. And third one is extended propositional calculus. Here you have to first find out A complement and B complement, then you have to do the intersection part. Intersection means minimum operator. So you have to do the minimum operator here, then you have to do the maximum operator, as union is there, maximum of this part and B, and you will get the answer. So I hope this is clear to all.
Yes, sir.
Okay. So let me go to the next part. So you are done with the fuzzy proposition, you are done with the fuzzy implication. Now this is fuzzy inference. What is inference? Inference is drawing a conclusion or a new rule from more than one fuzzy rule or combination of fuzzy rules and fuzzy proposition. So you would have till now you have studied this fuzzy proposition, then you have studied this fuzzy rule or fuzzy implication, and now you are studying this fuzzy inference. So fuzzy inference is if we have more than two rules, then how we will draw the conclusion out of it, that is fuzzy inference. So this more than two rules could be one rule or one proposition, or two rule or one proposition, or three rules. So that can vary, but fuzzy inference is drawing a conclusion or drawing a new rule from this fuzzy rule or fuzzy propositions. So these are basically of two types. One is generalized modus ponens. So what is generalized modus ponens saying? Generalized modus ponens is saying if first rule, this is your first rule because this is a conditional statement. If x is A, then y is B. This is your conditional statement, that means fuzzy rule. And this is your proposition, x is A dash. So if we will join this two, you can say a plus operator or any operator. If drawing the conclusion from this two, we got this result, y is B dash. So this type of thing is known as generalized modus ponens. And second is generalized modus tollens, GMT. In GMT, what you do is, if first conditional statement is same as of generalized modus ponens, but second proposition is different. Here proposition is y is B dash. Proposition in your first thing modus ponens is x is A dash. So this is changing, and when this is changing, you will get this result, x is A dash. So I know this could be a little confusing, but if this is solved, then you will get this formula. We have to find out this new rule, right? Y is b dash, so b dash will be a dash. This is called as max minimum composition. This circle, small circle, and so a dash max minimum composition with Rx and Y. Rx and Y is your Zades max min rule that I have discussed in the previous slide. I will tell you how to find out that Zades max min rule. So if you are given with this rule, and if you are given with this proposition, then you will get this by this formula. So in next part, if you are given this rule and if you are given this proposition, then you will get x is a dash by this formula. Here a dash will be equal to b dash max min composition r x y. R x y again this is Zades max min rule. So I hope this is also clear. Yeah, b dash means complement of b, a dash means complement of a. Similarly for here also. So is this clear?
Yes, sir. Sir, can you give the example in example, sir?
Example, actually it is big example, but once I will give Zades max min rule, you have to do the see, I will give you example of how to do the max min composition. I have also given in the first lecture also. This lecture also I will give you how to give the max min composition, and I will also tell you how to find out this Zades max min rule. So if you will have this, and if you will have this, then you can do the rest.
Composition, sir.
So is it okay?
Yes, sir. Okay, sir.
Okay. So next thing is your defuzzification. Now the three things that we are discussing that fuzzy proposition, fuzzy implication, and fuzzy inference. There we are interested in finding the fuzzy membership function, not the elements. There we have elements. We are interested in finding the membership function. Now in this fourth case, that is defuzzification, we are doing the reverse. We are finding the crisp value, or we are finding the elements. So actually a fuzzy graph, you I think no, fuzzy graph look like this. This function can be anything else, but actually a fuzzy graph look like this. And till now what we were here, this is your membership function and this is your element. Right, so till now what we are interested in y-axis. We are interested in here, somewhere like here. We have elements, and we are interested in finding the mu as of now. But in this defuzzification, what we will do is we will do the reverse one. We have mu, like if we have this mu, so now we are interested in finding the x value. So x value could be here also, or x value for here, this could be here also. So now we are interested in x-axis. I am putting a star over here. So now we are interested in finding the elements. So this method is known as defuzzification. So let me erase this. Okay, so this I will explain you by example. So here we have a linguistic term hot, and we have for this hot we have this fuzzy set. So these are your elements: soft drink, milk, tea, coffee and soup. These are your 5 elements, and this have this membership function. For soft drink, the membership function for hot is 0.1. For milk, the membership function of hot 0.5. For tea, the membership function for hot is 0.8, coffee 0.7 and soup 0.8. So now if the question is which is the crisp beverage that is hot, so how you will find it? Now you will say hot is everything with a membership function of something, but we are interested in which is the crisp beverage that is hot. Now for this, what we have to do? We have to do this defuzzification. Now we have membership function, but we are interested in finding the crisp beverage, that is which of the beverage is hot. So now we are finding elements, not membership function. So that is known as defuzzification. So defuzzification is done by this following 4 method. One is lambda cut, second is weighted average, third is maxima method, and 4 is centroid methods. So example of maxima method is your height method. Now in height method, what you do, you take the maximum one. But yeah, height method is only applicable if your membership function are unique. Here you can see T has membership function 0.8 and soup has also membership function 0.8. So height method is not applicable in this case. So if you say soup is not there, if we hide this soup and we have only T, so by this maximum method, maxima height method, your crisp beverage that is hot will be T. If soup is not there, I am putting this condition. If soup is not there in the first example, height method, then you will say your crisp beverage that is hot is T, because it has got the maximum membership function. So this is your maxima method or maxima height method. Second is first of maxima. Now here you have 2 maxima. Let me erase this. Okay. Now you have got 2 maxima, right? T as well as soup. Now by first of maxima, we consider the first element that is maximum. So what is the first element that is maximum? T has the maximum membership function. So again our answer would be T, because it is first of maxima. So this is also clear. Now C, last of maxima. Last of maxima, we have T and soup as with maximum membership function, and we are interested in finding last of maxima. Our last of maxima will be soup, because this is the last element with maximum membership function. So C is also clear, and D is mean of maxima. Mean of maxima is not applicable for this example because it is not a numerical element example. This is a linguistic element example. But if you consider T as if you consider T as your third element, and if you consider soup as your fifth element, then according to mean of maxima, you have to do 3 plus 5 by 2. That is, fourth element will be your mean of maxima. So I hope this 4 methods are clear.
Sir, if 3 unique membership value there.
Three same membership value, right? T soup and maybe soup 2, right? With
Yes.
0.8. Now mean of maxima will be find out. If I say your T is your third element, soup is your fifth element, and and another element with 6. Then 3 plus 5 plus 6 by 3.
7.
Yeah, what will be the answer? 3 plus 5, 8 plus 6, 14. 14 by 3. 14 by 3 is what? 4.67, right?
Yes.
Yeah. So that will be your answer.
Coffee.
Not coffee exactly, that will be your answer. Yeah, 4.67 is close to which element? 4.67 is close to fifth element.
Soup.
So soup.
Okay. Okay, sir.
Okay, so this is clear, I hope. Simple thing, not much complex. Second is centroid methods. So centroid method, we have three centroid method. One is COG, center of gravity. Second is center of sum, COS, and third is center of area method. Center of area or center of largest area. This is area written, but actually this is center of largest area. And third is weighted average method. So first thing is clear. For second thing, we will move to the next slide. So COG method or center of gravity method. In center of gravity, what you will do is you will put this formula, summation of xi into mu c xi. So mu c is your membership function for this element xi. So xi into mu xi divided by summation of membership function, all membership function. So this is clear by the formula?
No, sir. No, sir.
No. Okay. So xi, what in the top numerator we have? In the numerator we have summation of xi into mu c. Like if we again number this element as 1, 2, 3, 4, 5. So 1 into 0.1 plus 2 into 0.5 plus 3 into 0.8 plus 4 into 0.7 plus 5 into 0.8. Right? So numerator is clear, right?
Yes, sir.
Okay. Now denominator. In denominator you have to sum all the membership function. 0.1 plus 0.5 plus 0.8 plus 0.7 plus 0.8. So you do the calculation, whatever you will get, that will be your answer.
Yes.
Okay, so this is clear. Now second is COS, center of sum method. Now this center of sum method is used if you have membership function of this type. You have some membership function of this type, or you can say you have some geometrical membership function. So you see this membership function is of geometrical shape triangle. Then this membership function is of geometrical shape trapezium. This membership function of geometrical shape of your again a trapezium. So yeah, trapezoid or trapezium. So here how you will find out by xi. Xi is the center of geometrical center of this figure. So in case of triangle, geometrical center we always consider x-axis, not y-axis. So if this is your 0 and this is your means 10, so geometrical center of this figure will be lie at 5. Clear?
Sir, yes.
0, 10, geometrical center 0 plus 10 by 2, 5. So you got this geometrical center. Now you find out the area. See, this will be given, this mu will be given, like this mu will be 0.5. This mu will be 0.5. So now area you can find out. Area you can find out by half into base into height. So half into base is your 10, height is your 0.5. So you will get the answer. So you will get the first term, that is x1 AC1. Now similar thing you can do with x2 AC2 and x3 AC3. So your numerator is clear. Now for denominator you have to add the area, that is A1 plus A2 plus A3. So solving this you will get a crisp value x star. So this is your center of sum method. So this is clear, I hope.
Yes, sir. Yes.
Okay. Now third is center of largest area. Now in this figure, what do you think is the largest area? C1, C2 or C3? If I name this figure C1, C2 and C3, so which one has the largest area?
I think C3.
Yeah, C3, of course C3. So largest area is C3. Then you have to only do center of this area. So center of this area will be here. If this is your 10 and this is your 18, then what will be the center of this? 10 plus 18 by 2, that is equal to 14. So this is your center of largest area. This is the most simpler of this three. So I hope this is clear, right? 10 plus 18 by 2. Okay?
Yes, sir.
Okay. Now last one is average, weighted average method. Weighted average method is very similar to your discrete membership method. Only this similar to this two. This two is applicable for geometric figures. This is also applicable for geometric figure and geometric symmetrical output membership function. What is symmetrical output membership function? Here all these are symmetrical output membership function. Symmetry is symmetry about x-axis. Like if you will put a mirror in between, then you will get the same figure here and here. This type of membership function are called symmetrical membership function. And if I take this triangle, this is not symmetrical, because here if you will keep a mirror in between, here this part is different, this part is different. So your weighted average method is only applicable to this type of membership function and not this membership function. This is the only thing, weighted average method. So I hope theory is clear.
Yes, sir.
Okay, so this is the theory part. Now we will move to the important part, that is solving the assignment. So assignment is based on these 5 topics: fuzzy proposition, fuzzy implication, fuzzy inference, defuzzification technique 1 and defuzzification technique 2. So this is our first question. So this is a fuzzy set with the linguistic term old, and you can read this fuzzy set. It has got 1, 2, 3, 4, 5, 6, 7 elements. First element is your 20.1, second element is your 30 membership function 0.2, third element 40.4, 50.6, 60.8, 71 and 81. Now question is asked to find the lambda cut, lambda 0.5, and these are your four options. So is anyone interested to guess the answer?
I think, sir, B option.
B option. Okay, anyone else? You can also write in chats also, guys. You can all write in chats also what you think. So I encourage everyone to write the option that you are guessing in chats.
Option C.
Okay, option C. Very nice. Anyone else? Write in chats. It will be better for me. Okay, Divya Gupta is telling C. Yes, Nita Patel is also telling C. Yeah, Jaya Navanithan is also telling C. So let me show you the answer, how to do this. So lambda cut. Lambda cut is a type of defuzzification technique. Yeah, I have discussed defuzzification technique, but I have not discussed lambda cut, because now I will discuss with the help of this example. So lambda cut means you will the answer would be elements with lambda greater than this membership function. So what are the elements with lambda value greater than or equal to 0.5? So 20, no. 30, no. 40, again no. 50, yes, it is greater than 0.5, greater than equal to 0.5. So 50 will be okay. 60, again it is greater than equal to 0.5. 70, greater than equal to 0.5. 80, membership function greater than equal to 0.5. So these are your answer: 50, 60, 70, 80. So your answer will be C. So solution, this is your solution, lambda cut. As I have told you, lambda greater than equal to 0.5. So greater than equal to 0.5. These are the four elements: 50, 60, 70, and 80. So this is your answer. Another thing I want to get to your attention is, here it is written only lambda cut, but if it is written strong lambda cut, then what you do is you take greater than lambda. Here you are taking greater than equal to lambda, but if it is telling you to find out strong lambda cut, then you do only greater than lambda, elements with membership function greater than lambda. So this is the thing I want to tell you. So answer, many of you have guessed right. So answer is C. So I hope this question is clear to everyone.
Yes, sir.
And about the strong lambda cut, difference between lambda cut and strong lambda cut.
Yes, sir. Yes.
Okay, so this first question is over. Now second question: which of the following operator is not used to interpret A coupled with B? This question I have also discussed in theory part, right? So I want answer from all of you. Please write it in chats.
Maximum.
Maximum. Anyone else? Yeah, Divya Gupta is telling D. Neeta Patel is telling D. Jan Navneethan is telling D. Anyone else? Yeah, and Nantha Kumar V is also telling D. So yeah, let's go to the solution for this. So yeah, interpretation of A coupled with B. So there are your T norm operator for this, and out of this four, your maximum is not a T norm operator. So your answer, sorry, so if I will write like this, you would think this is not the option. Okay, so your correct answer is D, because all the other three are your T norm operators, and maximum is not a T norm operator. So this is your answer. This again, I have taken the snap from your NPTEL thing and put it over here for your simplicity, and the correct answer is D. So I hope this question is clear to all of you.
Yes, sir.
Okay. Now third question: the degree of truth value of fuzzy proposition is option A is either 1 or 0, option B is between 0 to 1, option C is interval 0 to 1 with 0 and 1 both inclusive, and D is any value in the universe. So what do you think about this?
The option C, sir.
Option C. Yeah, very good. Anyone else? Yeah, Shams Bhagya is telling C. Maruranjan Mohanty is also telling C. Okay, so this is straightforward. I have only started our class by this only. Fuzzy proposition means multi-valued proposition, and multi-valued proposition in between 0 to 1 with 0, 1 inclusive. So your first option is either 1 and 0. This is your crisp proposition, not fuzzy proposition, crisp proposition. this is first one is your crisp proposition between 0 and 1. Between 0 and 1 is nothing. Because between 0 and 1, 0 and 1 is not inclusive, so you can't tell it as fuzzy proposition. So this I cross it, this I again cross it. So your correct answer is C. In D, fuzzy proposition, truth value is always between 0 and 1. So this is also I am crossing it. So right answer is C. So this is only written. Yeah, fuzzy proposition versus crisp proposition. This theory is this theory I have put for your clarity. So this is a straightforward question, nothing to explain. Okay, I think someone joined in. Okay, so let's move. I think this is clear to you all, right? Anyone with a question? Clear, right?
Yes, sir. Yes, sir.
Okay, very nice. Now fourth thing. This is an important question. This is your this is how to find out maximum minimum composition, and maximum minimum composition will be used in that when you are doing the inference thing. I have told you there in the formula this dot is there, so their maximum composition will be useful. So I want everyone to focus on this question. So here these two fuzzy sets are given, not fuzzy sets, these are actually the membership function of the fuzzy sets. These are written in a matrix form, and you have to find out this R is P maximum composition Q. So how you find out this? You will find out. So yeah, anyone wants to guess option?
Sir, wait, sir.
Okay. So no problem. Let me tell you. This is a long question. So let me explain you. So. So there are two sets P and Q, and how to do the maximum minimum composition. So okay, someone is guessing option A, so we will see. So how to do this question? So you all have done matrix multiplication, right?
Yes, sir. Yes.
You all know how to do matrix multiplication. That I am assuming, right?
Yes, sir.
Okay. So what you do in matrix multiplication is that you focus a row of first matrix and you
the column of the second.
Column of the second matrix. So in maximum minimum composition you have to do the same thing. So how you will do it? You will do
minimum.
you will do just like your matrix multiplication. You multiply first element of this row with first element of this column. In here what you do, you put the minimum operator between first element of this row and first element of this column. So when you will I am putting one dot here and I am putting one dot here. So we are concerned with 0.3 and 0.9. So what will be the minimum of 0.3 and 0.9?
0.3, sir.
0.3. So we are selecting this one. So I am circling this. Now second what you do is you focus on the second element of this row and second element of this column. I am putting 2 dot for here and 2 dot for here. So we are concerned with 0.5 and 0.3. So so what is the minimum of 0.5 and 0.3?
0.3, sir.
0.3. So I am circling this. So now third I am putting 3 dots. I am putting 3 dots for 0.8 and 3. Sorry, there's some technical problem today I am facing. I will try to clarify this in the next class. So again this. So 3 dots for 1. So 0.8 and 0.1 we are concerned. So what is the minimum between 0.8 and 0.1? Sorry, 1. 0.8 is the minimum. So I am circling. 0.8. So I am circling this. So out of, now what you do is out of this 3, 0.3, 0.8 and 0.3, you find out the maximum maximum. So what is the maximum of 0.3, 0.3 and 0.8?
0.8, sir.
0.8. So your first element would be 0.8. So it would be out of C and D we are cancelling, because first element is not 0.8 in these two cases. So it would be in between A and B. So how to find out in between A and B, which one? See, these elements are same for this two. We can do is we can focus this element. This is 1 here and this is 0.5 here. So if we focus in second row and first column, and we do the same thing, 0 and 0.9, what is the minimum of 0 and 0.9?
0, sir.
0. So we are circling this. 0.7, 0.3?
0.3, sir.
0.3, it is already circled. And 1 and 1 and 1? 1.
1, sir.
1. So what is the maximum of this 3? 0, 1 and 0.3? 1, right?
1.
Yeah, so your option would be A. So I hope this is clear to all. This is clear, right?
Yes, sir.
Yeah, anyone, if anyone has any doubt regarding this problem, please ask, because this is one of the most important problem of your fuzzy set. No problem, right? So this is your solution. Yeah, don't go by formula, you will just get confused. You will just simply, just like matrix multiplication, you do the things and you would get the answer. So I am moving to the next question. I hope there is no doubt in this question, right? This is a very important question.
Yes, sir. Yes.
Okay. So then question number 5, and this is again an important question. This is your Zadis Max-Min rule, and here you are given with a set X with 3 elements ABC. You are given with the Y set with 1, 2, 3, and fuzzy set A with this elements and membership function, and B with this element and membership function. So so you have to determine the implication results. If X is A, then Y is B. So this you have to solve with Zadis Max-Min rule. So this I was telling that I will discuss this. So this is the question finally. So here you have to do is, you have to, someone is joining, excuse me. Okay, so Zadis Max-Min rule is simplified as A cross B union A cross Y. So how to do, so you have to solve this question in 3 parts. First you find out A cross B, then you find out A complement cross Y, and third part you do the union of both. So 3 part you do. So first part, A set is given, B set is given. You have to only do the minimum of this, because A cross B, and I have told you that if there is nothing written and only written A cross B, then you do the minimum of T-norm operator. So you just do the A cross B. So A cross B, how we will do? A cross B, see, you arrange this element of first set A in row form, and you arrange elements of second set in column form. So A, B, C we have arranged here, 1, 2, 3 we have arranged here. Now you do the minimum operator. Minimum operator, if we relate A and 1, A has membership function 0.1, B has membership function 0.3. So what is the minimum of 0.1 and 0.3?
0.1.
0.1. So we have written 0.1. So similarly you do this with all the elements. Now you do a and 2, 0.1 and
Point.
okay, 0.1 and 0.2. So
Two.
what is the 0.1 and 0.2? Minimum of 0.1 and 0.2. It is 0.1. So 0.1 you write 0.1. So similarly you do for all the elements. So you got A cross B, right? This portion, this is clear to all?
Yes, sir. Yes.
Yes, this portion will be clear to all. Now let's move to the second portion. Second portion is we have to find A complement cross Y. So A complement, how you will find out? You will find out by 1 minus the element. So 1 minus element in A. So A 0.9. 1 minus 0.1 is 0.9. Then B point. B
Four.
point. Yeah, B 0.4. C point.
9.
0.9. Very nice. So you got this A complement fuzzy set, right? Now Y set. I have seen in that discussion forum someone is writing where you find this Y. So Y, how you will find this Y? Y set is given, already set is given, and fuzzy and in crisp set we know the membership function of all the element is 1. So we are simply writing membership function 1 for all the elements. So you got how we got this Y set, right?
Yes, sir. Yes.
Okay. So now what we have to do? We have to do A complement cross Y. So again same thing, A complement cross Y is how to write Y. Okay, how to write Y. You got this, Jaya Navneetan? Y is already given, right?
Sir, always Y value is 111, the membership value.
Yes. Always Y value is 111 if nothing else is given.
Yes, sir.
Okay. So now you have to do A complement cross Y. So what you do is
Minimum.
minimum operator. So 0.91, what is the minimum? 0.9,
9.
right? 0.91 minimum 0.9. So you will see as 1 is the maximum, means if you will compare this membership function of A bar, A complement and Y, then the maximum is always 1. So as we have to do the minimum thing, so you simply write this elements only. So 0.9, 0.9, 0.9, 0.9, 0.4, 0.4, 0.4, 0.9, 0.9, 0.9. So you got this, right? Second part is also clear?
Yes, sir.
Yes. And now you do the union. Union means maximum of this two, right? Maximum of A cross B, A complement cross Y. So we have to do the maximum. So maximum of 0.1, 0.9 is
0.9.
0.9. Maximum of this 0.2 and 0.4 is
0.4.
0.4. So you got the trick, right? So this will be your answer. So which option it is? 0.9, 0.9, 0.9, 0.4, 0.4, 0.6, 0.9, 0.9, 0.9. It is B, right?
1.
So correct answer is B. Okay, so this is also clear. Now we move on to the next question. What is the following sequence of steps taken in designing fuzzy logic system? So anyone with this guess?
Fuzzification, rule evaluation, then defuzzification.
Fuzzification, rule evaluation, defuzzification. That is A, right?
Yes, sir.
Okay, so A is the guess till now. Yeah, Neeta Patel is also telling A, Jaya Navneetan telling A, Harshita is also telling A. So yeah. So in fuzzification, what you do is you have a crisp input. First you will do fuzzification. So first you have to do this fuzzification. Then you have certain rules, and by these rules you have to do this rule evaluation. And last step is defuzzification. So this is the diagram. Crisp output, you do the fuzzifier, you put the fuzzy rule, and if there are more than rules, then you have to do this inference thing, right? There are more than one rule, you have to always do that inference part, and after that you do the defuzzification thing. So your answer is A. This is very clear cut, right? This is clear to everyone, I think.
Yes, sir.
Okay. So we move on to the next question. Next question is P set is given, Q set is given. Now you have to do P union Q 0.6. 0.6 is your actually that lambda cut. So you have to, lambda here is lambda here is 0.6. So you have to find elements with yeah, I want you to guess it first. So anyone with guesses?
B.
Option B. Yeah, option B. Anyone else? Yeah, Jaya Navneethan is telling B. Anyone else? Okay, so let me tell you the answer only. So first you have to do P union Q, and how you do P union Q? You do the maximum. So 0.2 maximum is what? 0.2. 0.4, 0.3, 0.4, 0.7 for 0.5, 0.7 and 0.8, 1. 0.81, 1, right? So yeah, actually here this lambda cut is applicable for fuzzy set, and here you can think that this is a crisp set. Actually this is also a fuzzy set, but this question it is given a trick. This is given only to confuse you. So actually you can write this P and Q set with elements, right? First element you can say A, second element B, third element C, and last element D. So A, B, C, D with this membership function, and then again the same thing, that just you have to do the maximum part. P union Q means you have to do the maximum part. So 0.2, 0.4, 0.7 and sorry, this is your 1, right? This is, guys, this is 1. This is a mistake, typo here. This is 1. So 1. So so P union Q you got. Now you have to find the lambda 0.6. Lambda 0.6 membership function, elements with membership function more than 0.6. So elements with membership function more than 0.6. Which are the elements with membership function more than 0.6? C and D. So C and D, here the options are again given as fuzzy set, means that fuzzy part. So 0.7 you just write 0.7 and 1. So answer is your B. So this is clear, I hope, right?
Yes, sir.
Okay. Someone I think joined in. Nobody joined in. Okay. So let's move to the next question. Which of the following is not a defuzzification method? A is weighted average method, B is maximum method, C is centroid method, and D is minimum method. So anyone who wants to guess?
Maximum method, sir.
So someone is telling maximum method, that is B. Anyone else with guesses? Yes, Shams Bhagya is telling D. Anyone else?
Minimum.
Yeah, Jaya Navneethan is also telling D. Anyone else? Okay, so let me tell you the solution. So as I have already discussed this, these three are your defuzzification method: centroid maximum method, centroid method, weighted average method. And this minima method is not your defuzzification method. Minima is for your T norm, right? There is no maxima, there is only a minima method. But in defuzzification there is no minima method. These are the three methods you do defuzzification with. So your answer is D. This is a straightforward question, nothing to explain this. Okay, so question, so this is your 8. 8 question. Now we move to the next question. Suppose a fuzzy set X. Someone joined in, I think. Yeah. So this is your question. Suppose a fuzzy set X is defined as this is your fuzzy set. You can read which of the following maxima defuzzification method is not applicable to calculate the crisp value of X. So anyone who wants to guess?
Hide method, sir, because the unique value is there.
Yeah, very nice. Yeah, very nice. So I don't know who has told this, but he has told absolutely correct. So same explanation as the elements are not unique. So 0.8 is there twice. So hide method is not applicable. So your answer is D. So this is the thing, nothing more to explain. Okay, this is the question number 9. Now question number 10, which of the following defuzzification method is not a centroid method? So can anyone who wants to have a guess? This already I have explained you in theory part.
Center of mass.
Yes, someone is telling center of mass. Maruranjan Mohanty is telling C. Okay, others are telling B. Okay, so let me tell you the solution. As I have already discussed, this is a method: center of gravity, center of sum method, and center of area method are the 3 centroid method for defuzzification. There is no method called center of mass. So this is your answer. Answer is option B. So this also I have told you, nothing to explain more. So we will quickly go to the question number 11. So if X is A, then Y is B, else Y is C. Then the relation R is equivalent to what? So anyone who wants to have a guess?
Option B, I think option B.
Okay, someone is telling option B. Anyone else? Yeah, Harshita is telling C. Okay, Harshita is telling C. Anyone else? Divya is also telling C. Very nice. Shanks Bhagya is telling B. Okay, so let me tell you the answer. Actually, this part is your Zade's Maxwell rule. If X is A, then Y is B. And for this part, I have already solved the thing, right? That will be equal to A cross B union A complement cross Y. Zade's Maxwell rule. This part is clear, right? If X is A, then Y is B. This part. Can I get the response?
Yes, sir, yes.
Zade's Maxwell rule is this, and this is A cross B union A complement cross Y. Now here this additional part is there, else Y is C. So in place of this Y in Zade's Maxwell rule, you just put C here. So your correct answer will be B. So this is the thing. This is equivalent to your Zade's Maxwell rule, and this is your answer. So I hope you got it, how we reached this B option, right? Everyone?
Yes, sir. Yes, sir.
Okay, very nice. Now we will move to the next question. Question number 12. Generalized modus tollens GMT rule, which is as follows. Generalized GMT rule I have already discussed. Here A dash can be calculated as. This formula also I have discussed in the theory part.
Sir, option A, option C.
Option A, option C. Anyone else?
Option A, sir.
Option A. Okay, nice. Anyone else? Okay, so let me tell you the answer. Answer is option A. option C will not be there because here y is b dash, so you will inculcate this b dash somewhere, right? And here a is written, so option C will not be your answer. Your correct answer will be option A. So this I also have discussed in the theory part, nothing new here. And yes, this how to solve this Rxy is your Zadis
This max min.
sorry, there's some technical problem. Yeah, this Rxy is your Zadis max min rule, and this dot means you have to do the max minimum composition. So first you will be given b dash also. So you will be given b dash. You do the from this inference you just find out Zadis max min, that is Rxy, and what you do the max min composition, and you will reach to this a dash, which will be your answer. So I hope this is clear.
Yes, sir. Yes.
Okay. Now question number 13, which of the following is the correct mathematical expression of center of gravity method or COG method? So anyone wants to have a guess? Yeah, Nantha Kumar V is telling C. Okay, very nice. Anyone else?
Sir, option A.
Yeah, Divya Gupta is telling A. Someone else is also telling A. Shank Subhagya is telling C. So I have already discussed this in the first in that theory part only, and this will be option A. COG will be option A. This is not the correct answer. Your answer will be A. How you will calculate? I have already told you. You do the summation of element into your membership function in the numerator. Similarly, here integration is used because this type of membership function is a continuous one. If you have discrete one, you do the in place of integration, you do the summation thing. So again you have to do the summation of this membership function in the denominator, and from this you will get x x star, or the defuzzification crisp output. So this is clear, I hope, right?
Yes, sir.
Okay, very nice. Now we are moving on to the next question. Question number 14. Suppose a fuzzy set of old is defined by this. This is your age part 60, that is point when old is having membership function 0.2, then 65 membership function 0.4, 70 membership function 0.8, and 75 membership function 0.8. So the crisp value of old using mean of maxima method is
Plus 70.
72.5.
Yes, actually the answer will be 72.5. If 72.5 is given, then all you do 72.5, 70 plus 75 by 2, that is 72.5. But if this 72.5 is not given in your question, so if discrete elements are given like tea, coffee, something like that, in that case what you do is you take the approximate value. Approximate value could be 72.5 is approximate as 70. So here as 72.5 is already given, so you take the 72.5, a plus b by 2. So you got it, right? Why we have not written 70?
Yes, sir. Yes, sir.
Okay. So this is our last question for this discussion. So I want everyone to guess this. Given a statement, if mango is yellow, then mango is sweet. It is what? Fuzzy proposition, fuzzy inference, crisp rule, fuzzy implication. Someone is telling D, Divya Gupta is telling D. I want everyone to guess this. We have 16 participants. So if I would be very happy if everyone write this. Okay, Harshita is also telling D. Okay, very nice. Shanks is also telling D. So yeah, very clear. This I have explained you in the theory part also. If a conditional statement is given, that is a fuzzy implication or a fuzzy rule. So answer is D. C given as crisp rule, so not C. That is fuzzy implication or fuzzy rule. So answer is D. So I hope questions are clear, right? Anyone having any doubt in any part can please ask.
No sir, thank you sir.
Okay, we still have some 16 minutes left. So if anyone with any questions, anyone wants to ask anything, can please ask. Otherwise, we will close this session.
Sir, I forgot the assignment of week 2 due to the health issue. Then
See, I am only a TA for this course.
okay, sir.
So you have to mail to the NPTEL team. They will guide you.
Thank you.
Okay. Anyone else? Okay, Shanks is telling thank you. Okay, it is my pleasure to interact with you all.
Thank you, sir.
Okay, I think nobody has got no doubt. So I am terminating or closing the session of today. We will meet on the next Tuesday, 6 to 8 p.m.
Thank you, sir.
Okay, thank you. Thank you all. Okay.